Hi everyone, so today I'd like to go over graphing a quadratic function in standard form, but a special case. So I'm looking at this example, y equals x squared minus 8x plus 16. And before I do that, what I'd like to do is I'd like to review perfect square trinomials. Okay, so a perfect square trinomial is a special factor pattern when something's in the form, maybe something like this, where both the first term and the last term are perfect squares, the middle term is double the square root of those two numbers, and the last term is always positive. Now, we have spent time on perfect square trinomials if you're in my class. If you're not, there's a video on perfect square trinomials I highly recommend. And in factor form, if you were to factor this, you're actually going to get the square of a binomial. You're going to get actually two factors, but they're identical factors. So if you didn't recognize it as a perfect square trinomial, you would get this. Okay? So, and they're the same. So I always encourage students to write it like that. So that means that if they're the same factors, and the factors are what lead us to the X-intercepts, this is going to actually change some things for us when we're graphing, and I want us to just be aware of it. Okay, so here, let's go back to that graphing that. So if I want to find the vertex, I do negative b over 2a. So I'm going to do negative 8 all over 2 times 1, which is just 2. So 8 over 2, which is 4. Okay, if I plug that in to get y, I get 16 minus 32 plus 16, which equals 0. So you're going to see that the vertex is 4, 0. Okay, and then the axis of symmetry would be x equals 4, and the y-intercept would be 0, 16. Remember the constant point. Okay, so then we're going to go back to our symmetry point. We would normally then find our x-intercepts by setting y equal to 0. And remember, I like to put the 0 on the opposite side, so use the symmetric property. And I recognize this is a perfect square trinomial, or a PST. And so in factored form, I get x minus 4 squared equals 0. If I take the square root of both sides, I get x minus 4 equals 0. So x equals 4. So 4, 0 is an x-intercept. So that's something we have to notice, is that the vertex actually is the x-intercept. And so if I go down here, I'm at 4, 0, 1, 2, 3, 4. I really can't use the x-intercepts on my graph, so I actually have to make sure that I get my y-intercept in there, which is 0, 16. So I'm going to count these as 2, right? 2, 4. So 2, 4, 6, 8, 10, 12, 14, 16. So 0, 16, 4, 0. So that means that I'm going to have a symmetry point at 8, 16. Is that 8? So 1, 2, 3, 4. Yeah. I can't. There we go. So then there's my parabola right there, and this point would be 8, 16. So now I have my symmetry point of 8, 16. Okay, so it opens up because it's a positive a value. My domain, again, negative infinity to infinity. And so it opens up, and my vertex is 4, 0. We look at the y-coordinate of the vertex. So 0, infinity. All right, that's it. Have a great day.